Hello students, welcome to Satya's Mathematics. In the video, we will see chapter 2 complex numbers, exercise 2.5, sum number 1. Find the modulus of the following complex numbers. So, modulus of any number is nothing but the absolute value of that number. The absolute value is always positive. So, yeah, modulus is always positive. Now, modulus of any number is given by distance from the origin to that number. So, distance always positive அதை நம்ம denote பண்ணுவோம். So, modulus of any number is always positive. But modulus of complex number நம்ம எப்படி denote பண்றதுங்கிறத first பார்க்கலாம். Any complex number that is equal to x plus iy can be considered as a point x comma y. இந்த பாயிண்ட் plot பண்ணனும்னா from origin to x distance எடுக்கணும் real axis ல. So this distance is x. From origin to y distance on the imaginary axis எடுப்போம். So this point is nothing but the complex number z of x comma y. Modulus of the complex number z is given by distance from the origin to the complex number. So இப்ப பாத்தீங்கன்னா நமக்கு இங்க ஒரு right angle triangle form ஆயிருக்கு. This triangle is a right angle triangle. In the side x, the length y na, this also will be y. For any right angle triangle, hypotenuse square is equal to sum of the squares of other two sides. So distance from origin to the complex number is modulus of z. Hypotenuse square is equal to modulus z square is equal to sum of the squares of other two sides. X square plus y square. So modulus z square is equal to x square plus y square. Now, what is modulus z? Modulus z is given by taking root on other side. So root of x square plus y square. This is the formula for finding a modulus of complex number z. So for any complex number z, modulus is given by root of real part square plus imaginary part square. X is nothing but real part, y is nothing but imaginary part. Property for the modulus of z is modulus of z square is equal to z into z bar. Yeah, modulus of z square வந்து z into z bar. Already we know the formula. Product of any two complex numbers x plus iy and the conjugate x minus iy is given by x square plus y square. So what is x square plus y square? Modulus of z square. So modulus of z square என்னது? Z into z bar. This is z and this is z bar. This is the conjugate. So modulus of z square is equal to z into z bar. Another property பாத்தீங்கன்னா modulus of z1 plus z2 is always less than or equal to modulus of z1 plus modulus of z2. Modulus of z1 into z2 பாத்தீங்கன்னா this can be written as modulus of z1 into modulus of z2. This is same for division also. Modulus of z1 by z2 we can write it as modulus of z1 by modulus of z2. அதே மாதிரி another property, modulus of z power n we can write it as modulus of z the whole power n. The next important property, modulus of z is equal to modulus of z bar. Modulus of z to modulus of z bar same இருக்கும். ஏன்னா modulus of z is x plus iy. x plus iy க்கு modulus எடுத்தாலும் root of real part square plus imaginary part square. அதே மாதிரி x minus iy க்கு modulus எடுத்தாலும் root of real part square plus imaginary பார்ட்டும்போது minus y square பண்ணும்போது plus y square தான். So we will get the same value for modulus of z and modulus of z bar. So the solution for first subdivision, let z is equal to the given complex number 2i by 3 plus 4i. Modulus of z is given by root of real part square plus imaginary part square. இங்க real part இல்ல, only the imaginary part we are having. So imaginary part square. I ஓட coefficient தான் imaginary part. So that is 2. So 2 square. இங்க பாத்தீங்கன்னா root of real part square 3 square plus imaginary part square 4 square. This is root 4 by root of 9 plus 16. Root 4 by root of 9 plus 16 is 25. So the modulus of the given complex number is Root 4 is 2 and root 25 is 5. This is the modulus of given complex number. Second subdivision, 2 minus I by 1 plus I plus 1 minus 2I by 1 minus I. Let z is equal to 2 minus I by 1 plus I plus 1 minus 2I by 1 minus I. So, இதுக்கு டைரக்டா நம்ம மாடுலஸ் எடுக்க முடியாது. If we are taking modulus directly, இங்க பாத்தீங்கன்னா plus இருக்கு. So, whenever we are considering plus between two complex number, the modulus will gives you the inequality. So, additionக்கு நம்ம modulus எடுத்தா inequality வந்துரும். First நம்ம given complex number simplify பண்ணிட்டு அதுக்கப்புறம் we will consider modulus. So, simplify பண்ணோம்னா in order to simplify, denominator complex number இருக்கு. So, multiply and divide by the conjugate. 1 plus I oda conjugate is 1 minus I. அதே மாதிரி 1 minus 2I divided by 1 minus I oda conjugate 1 plus I. So, multiply and divide by 1 plus I. Multiply term by term. 2 into 1 is 2 and 2 into minus I is minus 2I. Minus I into 1 is minus I. Minus into minus plus I into I square. Divided by denominator is in the form of x plus iy into x minus iy. So, we can write this as x square plus y square. X square is nothing but 1 square, that is 1. Y square also 1 square, that is 1. ஏன்னா y இங்கிறது I ஓட coefficient, that is also 1 here. 1 into 1 is 1. 1 into I is I. Minus 2i into 1 is minus 2i. Minus 2i into I is minus 2i square. By new denominator x plus iy into x minus iy formula இருக்கு. X is 1, so 1 square is 1. Y is 1, so y square is 1 square is 1. 2 minus 2i minus I is minus 3i plus I square is minus 1. Denominator 1 plus 1 is 2 plus 1 plus I minus 2i is minus I. Minus 2i square. I square is minus 1. So, minus 1 into minus 2 is plus 2 divided by 2. 2 minus 1 is 1 minus 3i by 2 plus 1 plus 2 is 3 minus I by 2. Combine the denominator 1 minus 3i plus 3 minus I the whole divided by 2. 1 plus 3 is 4, minus 3i minus I is minus 4i divided by 2. So, from the numerator take 2 common, 2 minus 2i divided by 2. Cancel ஆயிரும். Therefore, z is equal to 2 minus 2i. So, நம்ம given sum simplify பண்ணி 2 minus 2i கொண்டு வந்துட்டோம். Now, the modulus is given by root of real part square plus imaginary part is minus 2 square. So, it is 4 minus 2 square also 4. It is a root 8. Root 8 we can write it as root 4 into 2. So, 4 comes outside as 2. 2 root 2 is modulus of z.